The next question we're going to look at is question 5C, and we're given, again, slightly different information, but we're asked to do the same thing. So in question 5C, we need to find the equation of the chords of the circle. So we have circle S, which is x squared plus y squared minus 4x plus 6y minus 12 equals 0. So we find the equations of the chords of this circle of slope -1 and length 2 root 23. So the information that we have about the chord is that the slope is -1 and that the length is 2 root 23. Okay? Again, with our circle, first thing we want to do is find the center and the radius. So because this is in the general format, we use the coefficient of x and the coefficient of y. We know that 2g is equal to -4, 2f is equal to 6, therefore g is -2, f is 3, and the center of my circle minus g minus f is 2 minus 3. The radius is the square root of g squared plus f squared minus c. So that's the square root of -2 squared plus 3 squared minus -12, which gives us a radius of 5. All right. So now we have the slope of the chord and the length of the chord. Again, drawing a quick sketch, so we know what we're on about. We have our center point, which is the point 2 minus 3, and we have a radius of 5. Now we know that the slope of our chord is -1. Now there are actually two possible chords that we can make here. We can make a chord of length 2 root 23 with a slope of -1 on this side of the center, and we can also make a chord of 2 root 23 and slope -1 on this side. So we're going to concentrate on this side here first of all, and we're going to fill in as much information as we can. So when we are dealing with a chord, always construct a right angle triangle here. Because this is the midpoint and the total length is 2 root 23, each side here is going to be square root of 23, and we know the radius is equal to 5. So from this, we can say that the perpendicular distance, so we can find what the perpendicular distance is from the center to the chord. So the way we do that is using the Pythagoras theorem. So if we call this little distance here x, x is the square root of 5 squared minus root 23 to be squared, which gives us root 2. So we know that that little distance there is root 2. So we now know that we have a chord of slope -1 and its perpendicular distance away from the center is root 2. So here's where we have to kind of connect our coordinate geometry of the circle and coordinate geometry of the line. Because we know that the perpendicular distance from the center to the line is root 2, we can use the perpendicular distance formula. Now, in order to use it, the first thing we need to do is form a basic equation of our chord. So the fact that the slope is -1, if we insert that into the coordinate, into the formula, y equals mx plus c, m is -1, so y is equal to -x plus c, and bringing everything together, x plus y minus c is equal to 0. Now that we have a basic equation, this equation here can represent both of them depending on the value of c, so the c is the value that we're missing. So the perpendicular distance formula then is going to be the absolute value of a, which is the coordinate coefficient of x, so 1 times by our center coordinate x coordinate, which is 2, plus 1 times by -3 minus c, all over the square root of a squared plus b squared, which in this case is 1 squared plus 1 squared, and that is equal to the perpendicular distance between the center and the chord, which is the square root of 2. So first thing we need to do is multiply out and have a single line. So we have 2 minus 3, which is -1, so we have -1 minus c inside the absolute value sign, and square root of 1 squared plus 1 squared is root 2. Root 2 multiplied by root 2 is 2. Break this into its two parts, so we have -1 minus c is equal to +2, and minus 1 minus c is equal to minus 2, meaning that from this part here we get c is equal to, so minus c is equal to 3, so c is minus 3, and in this one minus c is equal to minus 1, so c is 1. So given that those are my two values of c, I'll just come back over here where I have a bit of space. My two possible equations of the chords are x plus y minus 3 is equal to 0 and x plus y plus 1 is equal to 0. So those are the two potential chords that I can have given that information there. All right. The other type of question I want to look at on this video is where we have a point of intersection of a line and a circle. So that's the information on chords. So connected lines and circles. So for the purposes of this, we're going to look at question 6, part B, which is also on page 331. And we're asked to find the point of intersection of the line L and the circle S. So we're given the line, which is x, all right, the line L, which is x minus 5y plus 4 is equal to 0, and the circle S, which is x squared plus y squared minus 6x minus 8y plus 12 is equal to 0. Okay, so there's a couple of different scenarios here that we can have between lines and circles. First of all, if there is only one point of intersection from our workings, that means that we're dealing with a tangent to the circle. If there are 2 points of intersection, we are either dealing with a chord or the diameter if it goes through the center. And lastly, a line may not connect a circle at all, so it may miss the circle. So those are 3 possible scenarios. So in order to solve this, we actually went through this back in algebra at the very beginning of 5th year, where we are dealing with simultaneous equations of a linear equation and a quadratic equation. Step 1 is to rearrange the linear equation here. So if we rearrange this linear equation so that we isolate one of the variables, x is the easiest variable to isolate because it's a single x, bring everything else across the other side, so we get x is equal to 5y minus 4. We can then substitute this value here into the quadratic equation anywhere we see an x. So our circle equation is x squared, so that's 5y minus 4 to be squared, plus y squared, minus 6x, so again we substitute 5y minus 4, minus 8y plus 12 is equal to 0. Multiplying out, 25y squared, so we have minus 40y plus 16 plus y squared minus 30y plus 24 minus 8y plus 12 equals 0. And now we need to tidy it up, so we're dealing with a single quadratic equation. So tidying everything up here, first of all dealing with the y squareds, we have 25y squared and 1y squared, so that gives us 26y squared. We have minus 40y, minus 30y, and minus 8y, so that gives us minus 78y. We have plus 16, plus 24, and plus 12, which gives us plus 52, and that equals 0. Now, in this case, we can actually divide across by 26. In that case, we get y squared minus 3y plus 2 is equal to 0. But you can use the minus b formula directly from here and you'll get the same answer. Now here we can either use the minus b formula or we can use factorizing. In this case, factorizing works just as well. And we get 2 possibilities. We get y is equal to 2 or y is equal to 1. The fact that we get 2 possibilities means that we're dealing with a chord of a circle because there are 2 points of intersection. So going back to our linear rearrangement, we sub our value in for y, so x is equal to 5 times by 2 minus 4, which is 10 minus 4, which is 6, and x is equal to 5 times by 1 minus 4, which is 1. So the 2 points of intersection are 6, 2 and 1, 1. So based on this video, I'd like you to finish off the questions in exercise 12 on page 331 and 332, and I'll upload the solutions to that exercise in a couple of days. Thanks.